This is an AS Further Mechanics 1 question on elastic collisions in one dimension. A particle P of mass 3m is moving in a straight line on a smooth horizontal floor. A particle Q of mass 5m is moving in the opposite direction to P along the same straight line. The particles collide directly. Immediately before the collision, the speed of P is 2u and the speed of Q is u. The coefficient of restitution between P and Q is e. Part A. Show that the speed of Q immediately after the collision is u over 8 times by 9e plus 1. So the first thing we want to do is to draw a diagram of what's going on here. So we've got these two particles P and Q. So let's just do two particles like this and we'll label them as P and Q. We're told that the mass of P is 3m, so we'll put that on, 3m, and the mass of Q is 5m. They start off by moving in the opposite direction to each other, so we're going to have the particles moving like this, and we're told the speeds of P and Q before the collisions are 2u and u, and we're also told that the coefficient of restitution between the spheres is e. Now we need to take a direction as positive, so I'm going to take to the right as positive, and to make things more straightforward, I'm going to take the directions of both of the particles after the collision as the positive direction. So if I get this wrong of the direction, then I'm going to get a negative answer for V, that's what I'm going to call this, or W. So let's start by writing an equation for the coefficient of restitution, also called the impact law. And so what we want is the speed of separation over the speed of approach. The speed of separation is going to be W minus V. W needs to be moving faster than V if they're moving in the same direction, divided by the speed of approach, which is going to be 2u plus u, so 2u plus u. So that will become W minus V is over 3u, and that's equal to E. So that will be my first equation here. And next we're going to write down an equation using the conservation of linear momentum, which is often shortened to CLM. So for this we want the total momentum before the collision. That's going to be equal to the total momentum after the collision. Now remember, I'm taking this direction as positive, so any velocities going in that direction will be positive, any going in the opposite direction will be negative. So let's start with the momentum of P before the collision. Now remember, that's just its mass times the velocity, so that's going to be 2u times by 3m. Then the momentum of this one, now u, notice is pointing the opposite way to my positive, so this will be negative u, so this will be negative u times by 5m. So that's the total momentum before the collision. Then after the collision, I will have v times by 3m and w times by 5m. Now we can tidy that up and we'll have 6mu minus 5mu is equal to 3mv plus 5mw. Now all of the m's will cancel out like this, and also I've got 6u minus 5u, that will just leave me with u, so I'll have the equation u is equal to 3v plus 5w. So this is going to be my second equation here. Now what I need to do is to take both of these equations and solve them simultaneously, and if I look at what I've got here, I've got an answer in terms of u. There's no v in my answer, and the speed of q immediately after the collision is w. So I want to make w the subject. I don't want to eliminate w, but I do want to eliminate v. So the best way to do that is to make v the subject of one of the equations, substitute it into the other. Now this looks like the easier one to make v the subject of, just looks slightly more straightforward than the other one. So we'll do that. So I'll take away 5w from both sides. So u minus 5w, and then divide both sides by 3. And I will get v is equal to u minus 5w all over 3. I'm now going to substitute that into this equation here. So I'll have E is equal to W minus V. Now V is now going to be U minus 5W over 3, and that's all over 3U. And from here, it's just about making W the subject. So let's times both sides by 3U. So I'll get 3EU is equal to W minus U minus 5W over 3. I'm going to times both sides by 3 to get rid of this fraction here. So I'll get 9EU minus 3W, is equal to 3W minus U minus 5W. Now really, because I'm subtracting all of this here, I should have brackets, and that means that I'll be subtracting U minus 5W, not just subtracting U and then subtracting 5W. So next step is to simplify that. So I'll have 9EU is equal to, now here I'll have 3W and then minus 5W, so that becomes plus 5W, so 8W minus U, so we're almost there. We'll add U to both sides, and that equals 8W, and then we'll divide both sides by 8. Now we need to give our answer in exactly the form that it's been given, so I will factorize out U here and then divide both sides by 8. So I'll get U over 8, and then in my brackets I will have 9E plus 1 because I've factorized it, and that's what W is there. So I get the result that's required. Remember, always leave it in exactly the form that they want, and don't try to bodge your answer if this doesn't look quite right and just write the answer down. Always work for your working, even if it doesn't quite work out to what they're asking you to get. Part B, find the range of values of E for which the direction of motion of P is not changed as a result of the collision. Now I've got the results here from part A there in red and the diagram from part A. Now because I took to the right as positive, then the direction of motion of P will not be changed if V continues in this same direction as it was before, which means that V needs to be greater than 0. It needs to be positive. So I can take this equation here and I can make this greater than 0. So I can say that U minus 5W over 3, which is V, that needs to be greater than 0. Now I can times both sides by 3 and I'll get U minus 5W is greater than 0. Now what I can do at this point is to take my W here and substitute it into this equation. So then what I'll have is U minus 5 times by W, which I have as U over 8, and that's times by 9E plus 1, and then that will be greater than 0. Then I'll expand out the brackets and I'll get U minus, now I'll need to multiply these terms together, so I believe that will give me 45 EU over 8, and then if I times the other terms together, that will give me minus 5U over 8 greater than 0. Now I can put together the U terms here, so I've got U minus 5U over 8, so that will leave me with 3U over 8 minus 45 EU over 8 is greater than 0. I'll times both sides by 8 and get 3U minus 45 EU is greater than 0. Now I can divide both sides by u. Now the sign is not going to flip because u is positive, because the direction of u is positive. Remember, when I use this u here, I made it negative. So I'm dividing both sides by a positive number. So no need to flip the sign, as I'll get 3 minus 45e is greater than 0. So from there, I can add 45e to both sides. So 3 is greater than 45e. Then I'll divide both sides by 45 and flip it around as well. So I've got e is less than 3 over 45, and that simplifies down to e is less than 1 over 15. Now e, the coefficient of restitution, always has to be greater than or equal to 0, but we found that e needs to be less than 1 over 15 for the direction of P to remain unchanged. In other words, it continues moving in the positive direction. When P and Q collide, they are at a distance d from a smooth fixed vertical wall which is perpendicular to their direction of motion. After the collision with P, particle Q collides directly with the wall and rebounds, so that there is a second collision between P and Q. This second collision takes place at a distance x from the wall. Given that E is equal to 1 over 18 and the coefficient of restitution between Q and the wall is 1/3, part C, find x in terms of D. So the first thing I want to do is to draw a diagram to show you what's going on. So both collisions are shown on the same diagram. It's not one underneath the other. It's just a later period in time here. So the first collision takes place at a distance of d from the wall. I've put in here the speeds before and the speeds after. Now v and w we can work out. Now that we know the value of e, so we can work these out here. These will be in terms of u. It's also worth indicating at this point that since e is 1 over 18, which is less than 1 over 15, we've already concluded that P continues on in the same direction. So we know that P is going to be moving in this direction. So this is the first collision. Q moves towards the wall at a distance of D, then it rebounds from the wall, and it's now got a different speed. That's going to be E times by its speed before, which is W. P is still moving at the same speed it was before after the first collision, and then they collide again, and this distance here is a distance of x. So I'm just going to put in here E is 1/3 for the wall here, and E for the collisions is going to be 1 over 18. And this is for the second collision. Actually for both collisions, isn't it? So I can change that and put E is 1 over 18, and that's the collision between these particles P and Q. Now the way to do this type of question is that we need to consider the time it takes for P to move between its first collision and its second collision, and the time it takes for Q to move between its first collision and the second collision. That time is going to be the same. The distances are going to be different. The speeds of the two particles are going to be different, but the time it takes between the two collisions is the same for P and Q. So because those times are the same, we can use speed, distance and time for particle P and particle Q and set these equal to each other and use this to find x in terms of D. So we'll start with particle P and work out the time it takes to move from its first collision position to its second collision position. Now before I do that, I'm going to substitute my E is equal to 1 over 18 into W and use that to work out W, and then use that to work out V. So my working is down here, so I'll get W is equal to 3 over 16 U. So let's put that in. 3 over 16u, or 3u over 16. So now I can substitute this in, or substitute my value of w in here to find v. So v will equal u minus 5 times w. So that's 3 over 16u over 3. Let's simplify that and see what we get. And that becomes 1 over 48u. So I'm going to highlight these because these are going to be useful for my working. So w is 3 over 16u and v is 1 over 48u. So let's start by working out the time it takes p to move. So I'll just call that p time, like this. The time is going to be the distance that it moves over its speed. Well, the distance that it moves is moving from this position, which was a position of d from the wall, to a position which is a distance of x from the wall. So the distance that it's moved is the difference between the two, which is going to be d minus x. So that's its distance. Divide that by the speed it's moving. Well, that's this 1 over 48u. And let's simplify that. And that gives us 48 d minus x all over u. Okay, so this is the time it takes for p to move, that distance. We're now going to do the same for q. Now with q, we're going to have to split up its journeys, because there's one journey that it makes going towards the wall at a speed of w, or 3 over 16. But when it returns from the wall, it returns at a different speed, because we need to do e times by 1 over 48u. So we're going to work out the time it takes for q to get towards the wall, the time it takes for it to rebound from the wall, and then add the two together. So I've called this the q time to the wall. So the time is going to be the distance, which is d, divided by the speed that it's going towards the wall, which is w, which is 3 over 16u. So 3 over 16u. We'll simplify that, and that gives us 16d over 3u. Now we're going to work out the time it takes for q to move from the wall. So this time the distance is x, and the speed that it moves from the wall is going to be the speed of approach times by e. So we're going to do 1/3 times by w, or 1/3 times by 3 over 16u. So 1/3 times 3 over 16u. Basically here we've just used this formula, v is equal to eu. And simplifying this, we will get 16x over u. So it is these two together that form the total time for q to move, and we're going to make that equal for the total time for p to move. So we now set this equation, which is going to be 48 d minus x over u is equal to 16d over 3u plus 16x over u. First thing we can do is to times both sides by u, so we'll get rid of those, and then divide both sides by 16. So this will become 3 here. So we're now left with 3 d minus x is equal to d over 3 plus 16x. Sorry, let's correct that, because I just cancelled out the 16, didn't I? So that just leaves x. The rest of this is just making x the subject. So let's expand the bracket. So 3d minus 3x is equal to d over 3 plus x. Let's add 3x to both sides of this. I'll do that here. So then I will have 4x is equal to 3d minus d over 3, which will give me 8 over 3d. and dividing both sides by 4, I will have x is equal to 2/3 d. And that's what I wanted, x in terms of d. So there's my final answer.